Hello everyone, welcome to the INS lecture series. This is lecture number 11 and in this session we'll be studying about the public key cryptography, the concept of this and the RSA algorithm. So what this public key cryptography is about? Public key cryptography is also known as asymmetric key cryptography, because actually in this case whatever things we have studied till now, we've studied many algorithms like DES, AES and some traditional ciphers. They all come under the category of symmetric cipher. In symmetric cipher we use the same key for encrypting and decrypting the message, but in asymmetric key we use two keys. There are two keys are used for communicating. One is called the public key while other is called the private key. So here in asymmetric key cryptography, two different keys are involved. One is the public key, other is the private key. Let us see how this system works. So what is the meaning of public key? So this key is intended to be shared openly and can be known by anyone. It is used for encryption and verifying the digital signatures. So public key, as the name suggests, public key is like suppose if we have an entity called as Alice, so she will distribute her own public key to everyone. So even the attacker knows the public key of Alice, and all the person who know who can actually get access to public key. Then this public key is used for encrypting the message and verifying the digital signature. Next is we have the private key. Now this key must be kept secret. So a person holding the private key, that person should not reveal the private key to anyone, and it should be only known to the owner of the private key. Now what is the use of this private key? This private key is used for decryption as well as creating the digital signatures. As you can see, public key is used for encryption, private for decryption. Public key is used to verify the digital signatures and private key is for creating the digital signatures. So these are the opposite things. So here the main idea what we say is the data which is encrypted by public key can only be decrypted by the corresponding private key. Okay, and a data which is signed using the private key can only be de-signed or unsigned using the public key. So this property allows secure communication between two parties before who have never met before. They can exchange the public key using the insecure channel and such as internet. Now let us take some applications. Let us see some applications of this asymmetric key cryptography. The first one is of course confidentiality. So when two parties want to share a secret message, they can use asymmetric key for encrypting and decrypting the messages. And second thing is signing the document. So this comes under the category of authentication actually. So if you want to sign any entity wants to sign a digital document, then again asymmetric key cryptography can be used to sign and verify the signature. So digital signature can also be generated using this. Now let's see the working of the system. Suppose we have two entities, Alice and Bob, and they want to share a secret message using asymmetric system. They also want to sign the document. So what they do before communicating, Alice and Bob, they generate a pair of keys. So Alice, they run some algorithm, and by using those algorithm they can actually generate a pair of private and public key. So this, in this particular example, this KA private, this is, let us assume this Alice private key, and KA public, this is Alice's public key. And then we have Bob. Similarly, Bob also uses algorithm and generates his own private and public key pairs. So this is Bob's private key and this is Bob's public key. Now after generating the keys, what they will do, Alice and Bob, they will share their public keys through insecure channel. So Alice shares her public key with Bob and Bob shares his public key with Alice. Of course it can also, that public key can also be intercepted by any adversary or any attacker. So after sharing the key, what Alice will know, Alice knows her own private key, her public key and public key of Bob, and Bob knows his private key, his public key and public key of Alice. So how confidentiality can be achieved using this concept, the concept of asymmetric cryptography? So what will happen? Let us assume that to send a secret message to Bob. Suppose Alice wants to send a secret message to Bob. So what does Alice do? Alice encrypts the message using Bob's public key. So this Bob's public key is with Alice. So Alice will encrypt the message using Bob's public key and send it to Bob. Now this how strong this algorithm is, that a message which is encrypted by using Bob's public key can only be decrypted by using Bob's private key. Now this private key, this message which was encrypted using Bob's public key can only be decrypted by using Bob's private key, and because only Bob possesses that key, so nobody else will know what the contents of the message except Bob, and we assume that no other key can decrypt the message except Bob's private key. So because only Bob possesses this private key, hence no attacker will be able to decrypt the message. So Bob decrypts the message with his private key. Now similarly, anybody who wants to send a message to Alice would send the message by encrypting it with Alice's public key, and Alice would decrypt it using her own private key. This is how the confidentiality can be achieved. Now second part is the digital signature. So what is the meaning of digital signature? Digital signature ensures that the message is sent by proper source, and not by someone else. So by source, the spelling mistakes there. Now suppose Bob wants to send a message to Alice, and that Alice must be ensured that the message has come from Bob and no one else. So here we are concerned with the authenticity of the message, that the message has indeed come from Bob and no one else. And here suppose we don't want the confidentiality part, we want everybody to know that the message, what the contents of the message are, but we only want to ensure that it has indeed come from Bob. So how does Bob do it? How does Bob actually digitally sign the document? So what it will be done, Bob first signs the message with his private key. So now what does Bob do? Bob takes the message and signs the message using his own private key, and sends the message as well as the signature. Now when Bob signs the message, he will get he actually has the message and also the signature. So Bob will send these two things, the message as well as the signature of the message. So these two things are sent to Alice. Now what Alice will do, Alice has to verify the signature, so she unsigns the message using Bob's public key. So this asymmetric cryptography, it ensures that a message which is signed using Bob's private key can only be unsigned using Bob's public key, and no other key can unsign the message. So here Alice has Bob's public key, so she can actually verify the sign. So this is how we can achieve this authenticity. Nobody else, Eve cannot send a message on behalf of Bob and sign the message, because Eve is not having Bob's public key. So this is how this can be done, signing and unsigning the document. So digital signature can be added and it can be verified. Now the last topic of this is RSA algorithm. So RSA is a widely used asymmetric cryptographic algorithm. Now this RSA is named after those who invented this, the Rives, Shamir and Edelman. So it is one of the first practical public key crypto system and is extensively used for secure data transmission. So this RSA involves two keys, of course, as we know, public key and private key. First we will see how the key generation is done. So this is the process of key generation. So let us assume Alice wants to generate a pair of private and public key. So how does she does? So we'll see this with steps. So first step is Alice selects two large prime numbers, P and Q. Now large means it may be like 150 digits or 200 digits number. So these two are very, very large prime numbers. Then second step, she multiplies P with Q and she gets the number N. Of course N will also be a very large number, maybe 300 digits, because P and Q, they are itself very large numbers. Then the step 3, she computes this phi, which is P minus 1 into Q minus 1. So suppose if, for example, I'm taking a small number, suppose if P is actually 7 and Q is 11, so P minus 1 will become 6 and Q minus 1, because this is 11, this becomes 10. Okay, so this is how phi is calculated. Then step 4, Alice selects a value E. Now this value E must satisfy two conditions. The first condition is that the value of E should be more than 1 but less than 5, which we calculated in this part. And second thing is E and phi should be co-primes. Okay. The meaning of co-prime is that these two should not have any common factors between them. Then the next step is Alice computes D such that D is equal to E inverse mod phi. So this is how she calculates D. Now after calculating or doing all these steps, Alice gets the value N, E and D. These three things will act as the key such that this D becomes the private key and E N they become the public key. So now after going through this algorithm, Alice will generate this E and D and she will distribute this public key to everyone and will keep this D secret with herself. Now how will this encryption be done? So this is the formula for encryption. Suppose Bob wants to send a secret message to Alice. Now Alice has already distributed her public key. So Bob has a plain text message. Suppose P is the plain text message and he wants to create a ciphertext. So Bob will use this formula. So C is equal to P, the plain text, raised to E, one of the elements of the public key, mod N. N is another element of the public key. Okay. So he will calculate C and C will be sent to Alice. Now Alice has to decrypt the message. So when Alice receives the ciphertext C, what she will do, she has to recover the plain text. So the formula she will use P is equal to C raised to D. Now D is only known to her, mod N. Okay. So this is how this particular algorithm works. Now any adversary, any attacker cannot recover this plain text. Okay, it is not an easy calculation. It is an impossible calculation even with best possible computations. So it is not possible to calculate this P. Only Alice can do because Alice knows this D. So this is how this strong algorithm is. So that's all for this particular session. Thanks for watching.